The elimination of ponding water on a roof surface extends the life of a roofing membrane, reduces structural burdens, and discourages mold and algae growth. Tapered polyiso insulation is a sloped rigid foam insulation panel produced to promote positive drainage and meet roof configuration and drainage requirements. This video is part of an educational series on tapered polyiso installation. This segment covers how to cut tapered hips and valleys and where they are used in a tapered roof system. Used on roofs at drains and roof intersections, tapered hips and valleys are made of rigid insulation panels. Using tapered hips and valleys creates a slight change in the pitch of the roof surface, allowing water to be properly directed. When a tapered panel is cut in half, two different types of pieces result. One having two high points and a low point. This piece is half of a valley. Two valley pieces are required to make a complete valley unit. The other piece has two low points and one high point. This is a hip piece, and like a valley, two are required for a complete hip. Hips and valleys change the water flow in a tapered system. A valley is installed low side to low side, which creates a trough. The water is directed toward and along this path. A hip is the opposite. Water will flow away from the intersection of the two hip pieces. Two separate 4-foot by 4-foot tapered panels are cut on a 45-degree angle to create either hips or valleys. Here is an X panel. HP stands for high point, indicating the thicker side of the panel. LP stands for low point, indicating the thinner side of the panel. When a tapered panel is cut in half, two different types of pieces result, one having two low points and a high point. This piece is half of a hip. The other half is discarded. Take one 4-foot by 4-foot piece of tapered polyiso. Using a chalk line, snap a line from corner to corner. Cut the panel in half along that line. Here you can see we have one half of our hip having two low sides and one high side. Take another panel and repeat this process on the other high point to low point axis. Once both pieces are cut, pair identical hip pieces together, joining them at the high sides. When installed into a system, a hip will move the water in two different directions away from the intersection of the pieces. One of the most common uses of hips is to facilitate the runoff of water along multiple roof edges. Pieces may be completed in the field or they are available prefabricated, which reduces waste and labor costs. Similar to creating a hip, a valley utilizes two pieces of the opposite half of the tapered panel. The half having two high points and a low point will be our valley. The other half is discarded. Take one 4-foot by 4-foot piece of tapered polyiso. Using a chalk line, snap a line from corner to corner. Cut the panel in half along that line. Here you can see we have one half of our valley having two high sides and one low side. Take another panel and repeat this process on the other high point to low point axis. Once both pieces are cut, pair identical valley pieces together, joining them at the low sides. The low side is always pointing in the direction of where you want the water to flow. Valleys are also available prefabricated, which reduces wastes and labor costs. Additionally, valley pieces are used in the creation of a tapered drain sump as transition pieces to aid in moving water. A roof sump is the section of tapered panels directly surrounding a drain in a roofing system. The sump, like the other tapered panels of a system, uses elevation changes to help direct water to a drain. The sump is generally comprised of tapered panels with a greater slope than the field. This ensures efficient drainage. Sumps are available in two forms, prefabricated or field fabricated. Many installers choose to field fabricate sumps. This adds time and labor. It also increases the amount of waste produced, adding to disposal costs. To complete a sump, you need 8 tapered panels. Remember, when creating a valley, each panel is cut in half, corner to corner. When a board is cut in half, the result is 2 types of pieces, one having 2 high points and 1 low point. This piece is a valley piece, and it's used in the construction of a sump. The other piece has 2 low points and 1 high. This piece is discarded as it is not needed in the construction of the sump. To determine the proper sump position, begin by measuring the distances from the center of your drain to the 2 different walls running perpendicular to each other. Then subtract 4 feet from each measurement. Use these differences to measure each wall to find your first corner. This should be the place where the 2 measurements would touch. This is the position of the first corner of the sump. Now measure from the corner 8 feet in both directions, parallel to the walls. Use your initial measurements to ensure a consistent distance from the walls. The points at which your 8-foot measurements end provide the second and third corners. Chalk a line between your 3 corners. Now you have the starting outline for your sump. Take the first valley panel and lay the low end at the drain and line the edges with 2 high corners along your chalked guideline. Lay all the panels in this same way. Install all panels snug against their adjacent panel. Continue this process until all 8 valley pieces are in place. Once your valleys are laid, cut your drain hole. Now that you have seen how a field fabricated sump is installed, we will show you the prefabricated sump installation process. A hinged target sump is a pre-cut, ready-to-install 8-foot by 8-foot factory-assembled sump. When folded out, it is ready to install and complete the job. As a single panel, there's no waste involved. To install, utilize the same process as shown previously in this video. Concentric circles printed on the hinged target sumps aid in cutting out the space for the drain. Hinged target sumps save time and labor, reduce waste, and dumpster costs, and with distinctive packaging are easily recognized on a job site. As you can see, prefabricated sumps will greatly reduce waste and labor while saving time on the job site. Hinged target sumps are available in a variety of thicknesses and slopes to accommodate different job conditions. They are pre-assembled with either glass-reinforced or coated glass facers in compressive strength of 25 psi. Another option when sumps are required are 4-foot by 4-foot sumps. These can be field fabricated or also come prefabricated. Now we will create a 4-foot by 4-foot tapered drain sump. To create this sump, begin by taking a tapered panel. In this exercise, we will be using a Q panel. Find the midsection of the panel by measuring 2 feet up the slope of the panel. Then chalk a line horizontally across the board using those measurements. Next, cut along this line. Keep the low side of the panel and discard the other half. Now find your midpoint of your newly cut board's low edge. Snap a line from that point to each corner of the high side of the board. Cut along these lines to create your first quarter of the sump. Discard the remaining pieces. Repeat this process 3 more times. Now that you have all 4 identical pieces, connect them at their low points to create your sump. Follow the same installation procedure as with the 8 foot by 8 foot field fabricated drain sump. Now that you have seen how a field fabricated drain sump is created, we will show you the prefabricated drain sump option. 4 foot by 4 foot sumps come shipped to the job site in a 4 foot by 4 foot bundle, wrapped in orange, similar to the hinged target sumps. 4 foot by 4 foot target sumps are pre-assembled with coated glass facer and have a compressive strength of 25 psi. They have a slope of a ½ inch per foot in starting thicknesses, ranging from a ½ inch to 2 inches. 4 foot by 4 foot target sumps eliminate 74% material waste that comes with field fabrication. Utilizing pre-cut products can greatly eliminate waste and labor to make the installation process more efficient. This concludes our Sumps and Miters video. You should now understand the creation and installation of hips, valleys, and tapered drain sumps. The Tapered design team takes the mystery out of tapered insulation with clear designs, streamlined quotes, on-site consultations, and education by some of the industry's best. The designers work directly with architects, contractors, and sales reps. Beyond quoting and designing, they can present various types of virtual and on-site tapered training. The Tapered team is here to help with any tapered insulation needs and provides the best solution for every roof. You can reach out to our Tapered department with any questions, design inquiries, or quote requests. If you'd like to learn more about tapered polyiso, check out our other videos on our channel.